Alright, so we're back with another Hack the Box video. Today we'll be doing Jarvis. So let's get started. Alright, so as usual, I've already run my Nmap scans of this box. Let me pull those real quick from my previous run. So if we do a full scan of all ports, we see there are 3 ports open, 2280 and 64,999. I kicked off a Durbuster scan of at least port 80. Yep, so we just got a Durb log. Alright, so we did the common word list. Looks like there's a decent number of results we got from it. So it's running PHP, as we can see by this index page here. That's the Apache server status page. So we'll keep in mind that it's running Apache. PHP-myadmin's running here. Could be a useful way to, if we get credentials or something, to try to log in. That'll give us some access to the server. So PHP info, that's interesting. We got robots.txt and some standard PHP-myadmin directories. No need to look at those probably. Okay, so that's the results of that scan, that Durb. So I'm actually going to go ahead and pull up a browser and take a look at the website. So we'll try going to Jarvis in the browser here, just see what the site looks like. Okay, so it's a webpage for a hotel. Got some stock photos. Looks very relaxing. So they let you book some rooms online, it looks like. There's also a menu. Can't really click on much here. Hope that's not a dessert. No, that wouldn't be a good dessert. Currently just poking around the pages. A lot of these buttons don't actually do anything. Can we sign in? That's not a valid link. So there appears to be two main pages that work besides home. So there's the hotel rooms, and we've got dining and bar. So just some photos. These buttons don't even work. If you look carefully though at the rooms page and you click on a room, you'll notice that, not the picture, you'll notice in the URL though that we'll have a parameter here with a number. And to me, that immediately stands out as a possible vector for SQL injection or some other injection. So we'll just try throwing something in there. So it's pretty obvious that we just caused something to happen on the database end. We broke the website. So there likely is some SQL injection. And just for the sake of time, I'm going to go ahead and throw a SQL map at it. Well, we could do this manually by hand. I'm not going to bother right now. So we'll throw it into SQL map. Oops. Maybe it didn't like that extra slash. It shouldn't matter. That's weird. Okay, so looks like we got banned. I don't know what we did that tripped it up, but it clearly didn't like something we did there. So we got to wait 90 seconds, it seems like. Real quick, though, while that's timing out there, we're going to check out. I'm going to see if I can curl that other port just out of curiosity. Okay, so perhaps that's actually where we're getting sent to through some firewall rules or something if we get banned. Alright, so we'll try not to be bad. Okay, so we're back on the site here. We're unbanned, it looks like, for the time being. So I'm going to go ahead and run SQL map again and hope it doesn't ban us. Okay, so we'll just say continue. Oop. All right, so it looks like we got a command shell using SQL Maps OS shell command after bypassing that annoying block message that we kept getting. So we're in. Time to start doing some basic enumeration, but probably should actually get a reverse shell first, so we're a little more stable here and don't have to rely on that website anymore, since we could get blocked again. Who knows? So start up some netcat here. All right, so we got our reverse shell. www data. And looks like we're in the web directory. There's a directory called band. So that's probably what we're getting sent to when we're hitting that band page. That would make sense. All right, so from here we'll do our basic privesc checks. We want to try to escalate to user somehow. So first thing I probably did would be run sudo -l. And that gives us something interesting here. We're allowed to sudo and run this command as Pepper, who is another user on the system. So let's take a look at this command here, or the script here. All right, so it's Python. I already have this copied over, so I'll grab a copy of that so I can look at it. All right, so let's look at the script here. It's Python 3. Good for them. A simple simplifier. So this looks like it has something to do with keeping out attackers, or at least detecting them. Who knows how effective it is. So when I get a file like this, I'll be looking for some standard functions that I know are possible vectors for command execution most of all. So I'd look for exec. So we have a command called exec ping. Not interesting yet. If they called os.system. So there actually is an os.system here. So that's going to be probably our hotspot to focus on to find a command execution opportunity. So it looks like they're trying some basic filtering or blacklisting of characters that shouldn't be allowed to be run in a command for fear of escaping and running multiple shell commands. But there's the thing about blacklists. They almost never work because an attacker will always find something that you didn't think of. In this case, they're quite obviously missing the $ and parentheses, which can be used to invoke a subshell. So if we send a command that looks something like... We don't even need the IP address, really. Well, sorry, the semicolon's not allowed. So we could just send a command that looks like this if we wanted to send ls, and that'll pass this blacklist here, and it'll be executed in this command, and this ls or whatever is in here will run in a subshell. So we'll actually get command execution as that user. I'm gonna also spawn a PTY here just so we have a little easier time. Alright, so I think I'm going to try and chuck my SSH key into Pepper's SSH authorized keys. There's obviously other ways I could do it. I could chuck up a MSF Venom crafted binary on there. That's one way to do it. In this case, I'm just going to try to chuck my, as I said, my SSH key in their home directory. Since I don't want to have to type all that, I'm going to just put a helper script on the target. Just want to make sure that I'm not trying another blacklisted command or character. Okay, so what we can do, since we can't type in the -e option for netcat, we can just throw that in a shell script and have our payload, or just have our command injection here just call our shell script. So I'm going to make a simple script here on the fly. All right, so this payload file, it's now just going to call netcat for us since we can't type in that dash. So I'll start my listener again. And we're going to run that sudo command. There you go. There we go. So we've got our shell. We are pepper now. Well, there we've got user.txt. All right, so we're user. Awesome. And now I'm going to go about getting a more stable shell on here, just so it's easier to prevesc to root. Okay, so finally, after some meddling around, I put that in our authorized keys. So now we can SSH in as pepper to Jarvis. All right, so we're in over SSH, so now we can try to do some real enumeration here. So off the bat, we don't have Pepper's password, so I'm not going to be able to try to sudo. Doesn't look like they have anything in sudoers anyway for Pepper, and that's fine. So standard enumeration. Nothing interesting there. I always check for set UID binaries because, well, at least in CTFs, those are pretty common ways to prevesc. All right, so right away, one of them stands out to me, and that's bin system control or system kettle. That's not the kind of thing you want to be set UID because, well, there's a lot of functionality packed into it for one thing. It shouldn't be set UID since an unprivileged user could use it to manage services and do nasty things, as we'll see here. So right off the bat, having used system control quite a bit and systemd in general, unfortunately, I know that system control can be used to edit unit files. Let's just take a look at that real quick. So I know it has an edit command. So there it is, edit name. So it can replace it can edit a file for a unit. So my thinking is if this is running as setuid, or if this binary is setuid, we could potentially create or read any file as root. So let's try that. I don't need any of that. Okay, so we're in Nano, which is unfortunate. And it's telling us this directory is not writable. Okay, that makes sense since it's a directory. But any sane text editor, including Nano, which Nano is not very sane, but it's got the features we need here. So we got a read file function. So Control R, and it wants us to insert a file path. So I'm going to do root.txt, and there's the root flag. So that's just one way to get this. The other way would be to create a new unit file. There's actually an example of it online. And I got a lot of messages during the machine's lifetime about this specific thing, and I got a lot of people who were following this verbatim and copying systemctl and trying to make it setuid. It was already setuid, on the box, so there was no need to do this or muck with that at all, or any of this stuff, which is pseudo. So yeah, we can do this here. Just make a unit file anywhere in the file system. So just make temp my service.service. Of course, Vim's not installed. Great. All right, so just like a normal systemd or systemd unit file. And so exec start is the key here. So we can put any command we want to run here. So we could do, probably don't even need the bin sh, but so here we can do reverse shell, just like several times we did before, as unprivileged users. And then we did an install section. All right, so that's our unit file. I know I could have just copied and pasted it here, but not needed. So systemctl, go into the man pages again here. It has a link command. There we go. So what link does is it takes a unit file that's out of the search paths, which typically are going to be lib systemd system and etc systemd system, which is where you put usually user configured unit files. The lib path being the system and packages where they put their unit files. So this link command lets us link a unit file that it's not in that search path into the search path. So we can give it an absolute path to our unit file. We put in temp. And so once we do that, we can use commands like start, even though it's not installed like normal. So what we'll do is that exactly. So now it's enabled. So there we go. So now it's registered that into systemd, so it knows about it. And what we can do now is enable it. I know we can enable it, but let's see if we can start it. Just see what happens. I should have a shell running before I do any of this. Okay, so that doesn't work apparently. Oh, okay, so it actually did run, or did try to run at least. I'm just gonna see if I can get away with putting, I don't know why they have the bin sh here. That seems unnecessary to me. I wonder if this has to be done. I don't know. Oops. Okay, so yeah, I just have to start it. I don't know why they have enable. I guess maybe you'd be persistent that way. I don't really know. That's the equivalent to enabling it on reboot, and now also throws in a start. But we don't care about anything past this. So, yep, we're root. And that's Jarvis. It was a pretty easy challenge overall. Once you get past that weird behavior on the website blocking you if you do make some weird requests. Other than that, though, it was pretty straightforward. Some textbook privs with SUID binaries that shouldn't be SUID. That's it for now. Thanks for watching. Come back for more later. All right, so we're back with another Hack the Box video.